Hey folks, in this video we're going to be discussing data types in Google Sheets query function. I think being able to work with data types is really important. And within query, you will need to understand the different types of data values you'll be working with in order to compose queries for yourself. We are going to be working with the data set that is in front of us here, which has most of the data types that you'll come into contact with. So we are going to be demonstrating how to call each of the data types, and we're going to be focusing on strings, integers, and dates. And then at the end, we are going to discuss some challenges that can arise, a situation specifically where you have mixed data types and that can impact the accuracy of your query. So we'll discuss some best practices around that. So what I'm going to do is I am going to go to my example tab and I am going to write a base query that is referencing sheet 1. And I am going to begin my query statement with a select where I'm going to select column A, which is our country name. I am going to run a count of column B so that I know the total amount of line items for each country. I am going to sum column D so that I know the total inventory for each country. I'm going to use the min method in order to identify the earliest date in the data set for each country. And then I'm also going to use the max in order to get the most recent date. I'm going to use a where statement where I'm going to call for anything that is not a null value in column A. And then I am going to group by column A, because anytime that you're using an aggregate function like count, sum, min, or max, you need to group to a value, especially when that value is not being counted, summed, min, max, any of that type of stuff. If you didn't have A in here, you wouldn't need group by, but because we have A, we have to tell query that we want to group it to A. And then because we're doing some math stuff in here, I'm going to use label so that we can change count B to total, and I'm going to add a comma so that then I can add in a label for the sum D column, which is tracking total inventory. So I'm going to change that header name to total inventory. And then I am going to use a double quote because I am done my query statement. I'm going to do a comma. I'm going to do 1 because I want headers, and I'm going to hit enter. And now you can see that I have successfully completed a query that gives me each country in my data set and provides me the total amount of instances, the total inventory, and the minimum and maximum date in the time series. So what we're going to do now is we are going to work through our where statement in order to show some examples of how to call the different data types. But before we do that, let's touch on what each data type is and what the data types are for the values in our example data set here. Countries in column A are examples of strings. Strings are values that have alpha characters, so they are words, they are letters. So anything with letters is going to appear as a string. Column B is an example of integers. Integers are whole numbers. There is a subset of integers, or a different type of integer, which is known as a float value, which is what happens when you have a period or a decimal point, and then you have numbers after the decimal point. With Google Sheets query, I don't believe that's an issue, but when you go into deeper sets of data exploration, understanding the difference between integers and floats can become important when you're trying to run math functions on things. Additionally, we have a date value in here. Dates are, in my opinion, the most challenging data type to work with. Date and time values are really difficult to work with. The reason for that is because they are ambiguous. This value here of 1/1/2019 could represent a couple different things. It could be a date, or it could be an instance where someone is trying to do 1 divided by 1 divided by 2019. Additionally, it could also be a serial number. So it requires more specification within the Google Sheets query statement when you attempt to work with a date value or a date. I have a video that focuses specifically on dates, so if you want to learn more about that, you can check that out. We're going to briefly touch on it and kind of talk about the high levels, but we're not going to dive as deep as that resource does. So what we're going to do now is we are going to go back into our query statement, and I'm on a Mac. I'm going to use a keyboard shortcut of Command Enter in order to add a line break into my query. And the reason for that is because I want your eyes to focus where we are doing our work here. I don't want you to get distracted by all the other things that are going on in our query statement. Right now, we're going to be focusing on where and how we are going to segment and explore our data by exploring different data types. So we're going to begin with strings. And the syntax for calling a string is like this. So I'm going to expand on my where clause, and I'm going to say where a is not null, I'm going to use the word and in order to add in an additional clause. And I'm going to say and a equals Canada. And you can see I've wrapped Canada in single quotes. I'm going to hit enter, and now you can see all we have is Canada in our data set. So when you're referencing a string, you need to wrap it in single quotes. You cannot use double quotes. If you use double quotes, you'll notice that the rest of the query changes its coloration, right? So all these highlighted values or characters have turned black. And the reason for that is because Google Sheets is going to give you visual feedback about the status of what you're telling it to do. And within our documentation, you can see that in our query portion of the query function, we need to have our entire query statement wrapped in double quotes. So if you wrap Canada in double quotes, you can see what happens here. It ends up excluding Canada. This is the only thing on screen right now within the query statement, I should say, that is not green. And the reason for that is because Canada is falling outside of the query statement. What you might be able to do is use double quotes like that in order to maintain your query statement. But that is not recommended, in my opinion. The only instance where I would recommend that is if you had a value in your data set that had an apostrophe like that. That is something that I've dealt with in my career. And the way that you can get around it is by using these two double quotes next to one another, because you're effectively tricking the query statement into believing that this is one query statement, and then this is a query statement, and then this is a query statement. It's kind of like using Scotch tape in order to join two things together. But if you are just working in a standard string with no apostrophes or anything like that, a single quote is the best practice syntax for referencing a string call within your where statement. Now, I want to just touch on real quickly that this equal sign is the representation for effectively saying where A is Canada. You can also think of it as where A equals Canada. They're both the same thing, but you cannot type in A is Canada. That will not work. You can say where A is not null. You can also say where A is null, but when you are referencing a value like this, you need to say equals Canada. If you wanted to exclude Canada, you could use what I call the diamond, which is a less than sign and then a greater than sign in sequential order, and then you'll see that we're getting everything that is not Canada. Cool, but for the purposes of this example, I just want to look at Canada. I want it to be uncomplicated, so we can just look at this one value here. So let's say that we wanted to exclude some values in here, right? So within our inventory from our data set, so if we go back to our data set, you can see in here that Some of the values for inventory are smaller than other ones. And for whatever reason, we might want to look at anything that is from Canada that has an inventory value that is above 46. And when it's above 46, or to make it a little bit easier, let's say above 40, we want to include that in our data set. So we can go back into our query statement, and in addition to saying where A is not null and A equals Canada, I'm going to add in a statement in here that says, and D, which is our inventory, is greater than or equal to 40. And you'll notice that when I entered in 40 like this, I didn't include single quotes, right? And now you can see that our inventory went from, I believe it was 480 down to 301. Yep, our total went from 480 down to 301. And the reason for that is because initially, when we just called for things that are Canada and they're not null, we got 480 total line items. But then we added in an additional clause that said, and D, which is inventory, is greater than or equal to 40, which then changed the total amount of values that aligned with our specifications, right? And you can see that when we are referencing numbers, we do not put single quotes around them. Numbers are referenced as they are. You just type them into the query statement. If you put a single quote around it, it will treat that as a string object. You do not want to do that. You can see that when we say, and it's greater than or equal to string object 40, it literally doesn't give us any results anymore. This is going to be a factor later on when we explore why you do not want to mix data types. But for the purposes of our tutorial today, strings need to be wrapped in single quotes. Integers need to appear without any quotes around them. And integers can be called in the following ways. You can reference that they're equal, right? So we have 10 instances where the inventory equals 40. You could say less than 40. You could say less than or equal to 40. You could say greater than 40. And you could say greater than or equal to 40. The final date value, the final, spoiler, the final data type that we'll be working with is our dates. So right now we have all 4 years worth of data in here with some segmentation relating to instances that are Canada, and the inventory is greater than or equal to 40. What we're going to do with our data type, or with our date type now, is we are going to say and C, which is our date column, equals, and then we're going to write in the word date, and then we're going to format it in a year, month, day formatting. So I'm going to type in 2022, 10, because that's the month, October, 01, because that's the day. And I'm going to hit enter. And now you're going to see in here that our minimum month is October 1st, 2022, and our max month is October 1st, 2022. And this is probably a good time to state, if it's not already obvious, that I am from the United States, and this is the way that I format dates. I understand that internationally and in other places it's not formatted this way. If you want to, you can change the format of your data in your query statement. You can say format, and then we could format, well, in this case we have to do min C, and we could do year, 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 month, month, day, day. And now you can see that I've reformatted the date without having to change anything in my data set. Cool. So that is an option. And again, I have a whole video on dates if you want to go into that a little bit further. Now, additionally, what we could do is we could say that it is greater than 10/1/2022. And this should change our query in here. So you can see now we have our minimum month as November 1st, 2022, and our maximum month as December 1st, 2022. And our totals are much different. We could also do greater than or equal to 10/1/2022. Let's expand the data set a little bit just so that you can kind of see the floor and ceiling that we can put on here. So now we've added 14 months to our segmentation, right? So our earliest date in here is now October 1st of 2021, and our maximum is December 1st, 2022. And what we could do is we could add another clause in here, and we could say, and C is less than or equal to date, and then we could put in 2022, 06, 01. And now you can see we are calling everything that is on or after October 1st, 2021, and before or on June 1st, 2022. So that's kind of a brief overview of some of the primary data types that you're going to want to be using in some of your analyses or your environments and so on. I think it's really good to get a feel for data types because it will empower you to write dynamic segmentation in line with your specifications. And one last tool that I want to leave you with is just some knowledge about what can happen when you mix data types. So I have two examples here where instead of using a country name or a person's name, we are going to be attempting to use serial numbers. And you'll notice that these serial numbers are nearly identical. However, the primary difference between them is that column A is a pure serial number with integers. So it is all numerical values. Whereas column F is a serial number that has become a string object, right? So it is an integer mixed with an alphanumeric character, which is then turning it into a string object. It's not even really a string anymore. It's become more dynamic than that, right? Because there are mixed values in there. And what you'll see is that our inventory in both column B and G are identical, and our query statement in column D is selecting sum B where A is not null. And as we discussed, you don't always need to have a group by statement if there is nothing to aggregate to, right? So if we added column A in here, like we wanted the serial numbers to appear, what'll happen is we're going to get an error, and you can already see the error here, where it's saying that you need to add a column in order to be aggregated. So you need to tell it what you want to group by, which in this case is column A. But if there's nothing to aggregate to, you can just run a math query in here. So you could do sum B, count B, you could do average B, you could do min B, max B, everything in between. But the second that you add in a column that needs some type of aggregation, you have to add in a group by statement. Okay, cool. So you'll notice in here that when we are running this query, we're getting 273. And you can see in column I, we're running the exact same query, but on columns F and G, and we are getting 273. Another thing that I want to point out to you is that the alignment in column A, B, D, G, and I, right? So all of these places that I am highlighting on your screen and mine are aligned to the right of the cell, right? You can see the numbers are hard right in all 5 of the columns that are highlighted. And then if you'll notice in column F, they are hard aligned to the left. Google Sheets is going to give you visual representations of when things are happening inside of the spreadsheet environment. The reason the columns A, B, D, G, and I all have right alignment is because those data types are numbers. Column F is aligned to the left because it is a string. That is important to know when you are evaluating a data set because your eyes can quickly identify some high level pieces of information about the data set that you're working with. That alignment consideration is going to become important as we add information to our data set. Now, I am not encouraging to do what I am about to do here. It's merely to show you what happens when data types mix. So in column A, we have integers. So if I add in another integer, so I'm going to add in 0, 0, 1, 1. Actually, I'm going to do a different one because that's not obvious enough. I'm going to do 1, 1, 2, 2. You can see we have a new serial number in here, and I'm going to add in the amount of 25, which is going to create the sum of our inventory to 298. I'm going to go into column F, and I am going to add in 1, 1, 2, 2, G. Doesn't matter, I could have put in any letter there. And I am going to add in 25. And you can see each of these have now gone to 298. Check out what happens when I add in 2233A. The alignment is now going to the left of the column. And when I add in the value of 2, nothing happens. When I go over to serial number and I add in 2233A and I add in 2, an additional value is added to the inventory over here. This issue over here is what happens when you mix numbers with non-numbers. You potentially will get an error where the query statement will not return the value because you are mixing in a data type that does not align with what it has come to expect. So we're gonna break this down just a little bit more over here. So I'm gonna add in 1, 2, 3, and I'm gonna add in 4, 5, 6, and I'm gonna add in 3, 4, 5, and I'm gonna add in 5, 6, 7. And what we're gonna do is, you know what, I'm gonna add in a header column too. Sorry, that was premature of me. So we're gonna say like serial number and amount. And we're gonna run a query on this amount. And we're just gonna do select A sum B, where A is not null. And we are going to group by A. And you can see we're getting those amounts in here. So if I added in serial 1, 2, 3, and then I added in 899, you can see that amount is adding up again. If I add in 3, 4, 5, and I add in 13, you can see that amount's going in there. And then we're going to add in a new value. We're going to say 4, 5, 6. And we're going to add in 10, and then we're going to add in one final value, and we're going to do 789, and we're going to do DK10. And you'll notice that DK10 is not appearing in this data set over here. That's because this is mixing data types, and it cannot run the math function on this value because it's not a number. So what Google Sheets Query does is it just omits it, right? So in this instance, you have bad data entry, which is going to impact your results, right? Like, let's say this is revenue. Let's say this is inventory. Let's say this is any business metric that you need to work with. If you have mixed data types like this and you're not aware of it, which can potentially happen when you have, you know, thousands or tens of thousands, and in some cases, hundreds of thousands of data rows, it can become a significant challenge when you have mixed data types in there. So you need to ensure that if you are going to run quantifications on stuff, or you're going to be entering data, you need to ensure that the quality of your data is as clean as possible. There's a saying that people will often use, which is garbage in, garbage out. That is an example of what you're seeing here. I am going to create another video that kind of talks about how to approach data sets in order to evaluate them, to quality assure them, to check them, all that type of stuff. So please check out my channel because that one will be coming. I hope you found this resource helpful. I know it was a long one, but I think it's a good thing to know, and hopefully you have a chance to work your way through it. I'm always interested in feedback, so please check out the comments section below, and I wish you the best of luck on your data journey.